down to 2 weeks left in the quarter. If you're planning to do retakes, I'd go back and watch the videos, do some practice problems. I mean, you really can just do whatever's in the video. We always do practice problems in the video, so that's what I would do personally. But especially if it's a review video, because that's pretty much the same problems that I want to put on the quiz. All right, so now let's go ahead. All right, so again, we said that an inequality means that we want something to be greater than or equal to, or just greater than, or less than or equal to, or less than, not just equal to. So the inequality symbol there is greater than or equal to if, I still didn't do what I wanted to do. There we go. Now we can do that. So if it was written differently, it might not be as obvious how you say it. You might see this instead of that. X over there. If you ever flip it, so a lot of you are going to want to flip it to solve for an equation because you just like seeing the x's on the left or whatever the variable is. You don't like the x's on the right. You can always flip the sides. But if I want to move 500 to the left and I want to move x to the right, what is the alligator thing that you learned? What was that about? Like I said, alligator. Alligator does what? Well, but what do we say the alligator does? How do you learn inequality? I know you know this. Every element. The alligator does what? Eats the what number? The bigger number. You don't remember that at all. I'll explain. When you learned in elementary school, they said, this is an alligator. Alligator mouth. The alligator is really hungry. So the alligator is going to eat whichever thing is bigger. So the mouth of the alligator is always going to be open up to the bigger number. So this side that it's eating is the bigger number. This side is smaller. Or to use our words that we're going to actually call it, this side is the greater number. This side is the lesser number. So in this case, this is the greater number. X is greater than or equal to 500 because that's the way the alligator mouth is pointing. X has to, if I'm going to flip the sides, X still has to be the greater number. It can't change into a different number. So I can't just leave the symbol. If this is the greater number, then the alligator mouth has to flip. A lot of kids will move things from one side to the other, but they won't flip the symbol. Cannot do that. You don't like having, I mean, you don't need to flip it at all to solve. It's still the same steps, but some kids just like seeing it on the left. So you got to remember, if you're going to flip it, and you, again, you don't read it, 500 is less than or equal to X. That makes no sense. You read it as still X, from where the variable is, X is greater than or equal to 500. Again, that doesn't come into play as much, like having to say it out loud, but it will come into play if you like switching the sides to solve. So always make sure you're thinking, okay, well, that side is bigger because that's the way the alligator's eating. I need to make sure that's always the bigger side if I move it on. All right. And then there's one tricky part that you have to know, which is where it will not be on this quiz. I'll introduce it real quick today, but it won't be on the quiz. Well, yeah, I'll still say any questions on that before we just kind of solve an equation. Remind you of the steps to an equation. So we're going to solve a two-step equation. We did this a long time ago. Some of you are probably still pretty good on it. Some of you probably don't remember how to do it at all. What's the goal of solving? So my definition of solving for a variable. You just want to do what? We just want to get the variable all by itself. So if that's the variable, I want to get rid of that somehow. I can't just scratch them out. Some of you think you can. I just want to get rid of those two things, and then X will be all by itself. So there was two different ways you could think about how to start for a two-step equation. How would we start? What do we get rid of first? 5 or 3? Why? How do you remember that? There was a way Miss Thompson said it, and then the way I said it was a little different, but ultimately it'll get you to the right starting point, no matter which one you use. How do you know 5? Who said 5? Who said 5? How do we remember which number to start with? Again, this is really just for a two-step equation, but you're going to see a lot of two-step equations, and this really, it'll only be two-step equations on Monday. So there's two ways you can remember it. Either the way I said it, save the variable term for last. So the term that has the variable in it, so that's a term for the variable, save that for last. The way Miss Thompson said it is start farthest away from the x. So whichever one you want to use, doesn't matter. It'll always lead to the same conclusion. Either save the term with the x for last, or start farthest away from the variable. Either way, we're starting with the 5. So how do we get rid of then, once we know where we're starting, how do we get rid of a number? One word answer starts with an O. We do opposite math. If we are, because really what we're doing is we're saying 3x plus 5, we could rearrange it if we even wanted to. So if we're adding 5 to 3x, because this is, and we're adding because that's plus, not because of that really. Well, if we're adding 5, or if we just think of that as a positive 5, the opposite is that. So now if I do that on one side, what's my number one rule? Got to do it to the other side. So -10, you have calculators now, so I expect math to be accurate. You do need to practice math because some kids get confused still. Some kids were trying to say -10, subtract -5. That is just -10, subtract 5. I subtracted 5 here, so I'm subtracting 5 from the -10. You can do it in a calculator, so I'm not going to spend any time at all on the math. I get that as my next step. And then now I think, okay, well, what's the math going on? What does 3x mean? What's the math going on? We're multiplying, right? So if that's multiplication, then I need to do the opposite again. Opposite of multiplying by 3 is dividing by 3. Well, if I do it on one side, I got to do it on the other side. So I get x equals -5. So that was solving a two-step equation. And I'm going to change it on the next screen. I changed this problem. Not sure why I made the next problem, that problem more difficult. Must have been, we must have already done some of the lesson. That, I'll come back to that another day. All right, so again, here, let me just actually change this. So let's quickly, you can just keep what you have. I'm going to solve this out real quick. We say -5, subtract 5, -15, divided by 3, 5, 3x divided by 3, and we get x is -5. So now we're going to do an inequality. Same exact thing. Same single thing. Not in this inequality. Well, there is one thing you have to take into consideration when you do inequalities. Other than that, you do the same exact steps as you did in an equation. So for those of you that remember equations pretty well, you're going to think this is an easy lesson, even when we get into more difficult equations. I want to get x by itself. So I do the exact same steps I just did. The only difference is my rule, if an equation is a rule, an inequality is a rule, my rule is just a little different. The left side has to be greater than or equal to the right side. So all that's really different in these two particular solutions is that this symbol, instead of saying equals, is going to just continue to be greater than or equal to. But I subtract 5, I start with the same number farthest from the x. I get -15, I get 3x. I divide by 3, divide by 3. I get x is greater than or equal to. Same exact thing. No difference at all the way you saw it. There's one trick we'll learn next week that you have to remember when you get to the very last step. Typically, it's the last step. It could be earlier, but for what we do in this class, it'll be the last step. And if that step doesn't happen, then there's no difference at all. Like it didn't happen in this particular equation, so it's no different at all from solving an equation versus an inequality. Now, what I do want you to know how to do is graph. I don't even plan on, I don't even think I'm going to put graphing. You won't even have to worry about it. You'll have to worry about it for your next quiz. We will still have a quiz the week right before break, like the last week of the quarter. It just won't go on this quarter. It'll go on next quarter. So you will need to know this relatively soon, not for Monday. Let's zoom all the way in so you can see a little better. So if we want to graph, I didn't do what I wanted to do. Shoot. Wait, where's my? Oh, there it is. All right. All right, so that's all we really need. So when it comes, once you have a solution, you will need to know how to graph. Graphing it with only one variable in the solution or in the equation, whatever you want to call it, is not real difficult, I hope. When we get to 2 and you're actually creating a line and then you have to like shade part of the graph, that gets a little tricky, but I don't think this will be this part of the quiz, not Monday, but the following week. I don't think this part will even be that much more difficult. So if I want to graph, if it would have said x equals 5, I would have just put a point on 5. That would have just been the answer. Right? I would have graphed, I would have said, hey, 5 is the answer. That's where my point goes. That's x equals 5. My solution is just the number 5. But is 5 the, actually negative 5. Is negative 5 the only answer that works in this? The rule is my solutions. Again, the variable is your solution. That's your answers. My solutions can be greater than or equal to negative 5 for this one. Now, if equal to 5 is part of the solution, then that means I have to show that by coloring it in. 5 is a solution. So I color it in, I fill it in, whatever you want to call it. But I also need to show that every number greater than 5, that's what the top part means. Every number greater than 5 is also a solution. So I have to shade the graph going that way. That's how I show that 5 is not the only answer. And it goes on forever. It continues to go to the right forever. Every number greater than 5, a billion, is greater than 5. So that is a possible answer. If you plug any of those numbers in to the original equation, so if you went back up to the original equation and you plugged any of those numbers in, it would make the left side greater than or equal to the right side. The number that you come up with when you solve, so negative 5, if you plug that in, it will always be the number that makes the left side equal the right side. That's how we got it, basically, is we set them kind of equal to each other. And then we just took into account that some answers can be greater than when we graphed it with. Let's see. And again, I'm not expecting you to get all of this today. You'll see what you need to be responsible for Monday in a second. Let's see. So we graphed it. That's it for the graph. Oh, I know what it was. Now, if the symbol would have been this, so let's say this part of it was gone. Let's say that or equal to part was gone, and it was only greater than x. So we solve it out. We get down to the bottom. And we say x has to be greater than negative 5. Is negative 5 greater than negative 5? Always seems to be tricky. Is -5 greater than -5? Is 1 greater than 1? Is 2 greater than 2? Is any number greater than itself? No, any number is equal to itself, not greater than. So -5 is no longer a solution if I don't have that little or equal to part. So the way I show that it's no longer a solution is I still put a circle. This is always the way you graph. You're always going to start by putting a circle on whatever the number is you came up with for your answer. But then you have to say, well, is that number a solution? Does that make like the inequality a true statement? Well, if this is my symbol, no, -5 is not greater than -5. So therefore I do not fill that in. Now we're going to do a cheat sheet version of that eventually. I'd rather you understand it. But I'm not going to first, but I'll give you the cheat sheet version next week. Any questions? I'm going to show you really quickly the tricky part of this, just so you can write it down. Oh, let's see, not that. Oh. Whoops, where is it? Oh, here we go. So let's do a problem real quick. So -2x plus 1 is greater than 4. I want you to solve. Actually, here, let's not do 4, even though you have calculators. I'm not going to give you a calculator right now. Let's do 5. I want you to solve that two-step equation. Come up with x. And we'll talk about the tricky part of inequalities. It's really the, I mean, other than just knowing how to solve more complex equations, this is the only difference in an inequality versus an equation when you only have an equal sign. Another 30 seconds. We're done, so I'll kind of let people wrap it up. So again, what's our, if it's a two-step equation, which is all that you'll see next Monday, how do we remember where to start? Got to get rid, if I want to solve, I got to get x by itself. That's what we said. X has got to be all alone. That's what solving means. I got to get rid of -2. I got to get rid of +1. How do we remember where to start? Which number? Again, you could say, wait, what did you say? Farthest. Okay, that's what I thought. So we could say farthest away from the x. The farthest away in this case, even though it's like sometimes it's a little closer than other times, still the -2 is right next to the x. So the farthest number is the 1. Or again, you can always think, save the x term for last. Either way, it tells you need to start here. I do opposite math. +1 means -1. Subtract 1. Well, then you subtract 1 there. -2x. What do we do now? Divide right by -2. So I get x is greater than -2. And that's, we say that our answer means that that's the solution to the equation. If we plug any number in that works for that, if we plug it into the original equation, it should make it a true statement, right? That's what an answer is. It makes the statement true. In this case, it's an inequality, not an equation. So it would make the left side greater than the right side. So give me a number that's easy to do math with, greater than -2. 1, right? I choose 0 or 1. 0 or 1 are always easy. So let's choose 1. Everybody has that part, right? We all solved it. You're good. So let's plug in 1 so that we can see that. All right. So let's plug in. Oh, missed that. So we say, okay, well, if I'm going to check my answer, -2 times 1 plus 1 is greater than 5. So that's -2 plus +1 greater than 5. Huh. -1 greater than 5. Cool. We solved it wrong. Like everybody came up with the same answer. What are the odds that we all solved it wrong? Probably pretty slim. But we didn't, that doesn't make the statement true, right? So here's the one tricky part about inequalities. And really, it's the only, I don't care how complex the inequality is, you still solve it the exact same way you solve an equation, except for one thing. This is that one thing. If you ever, next this one. If you ever here, let me zoom out. This is what you need to write down. This is your one trick or catchy part or whatever. This is the one thing you need to be aware of. Not on Monday, because I'm not even putting this on Monday. If you ever multiply or divide by a negative, and it doesn't matter if you have a negative on top, like it's not that you're dividing a negative number by a positive number. You have to actually be dividing or multiplying by a negative number. So I'll go back and show you what I mean in a second. You have to flip the greater than or less than symbol. So if it was originally eating the number to the left, you got to flip it to eat the number on the right. So you write that down, and then I'll go back and show you what I mean. This will not be on Monday's quiz, but it will be on following week, which will be your first grade for the 4th quarter. I can't believe we're almost in the 4th quarter. It's almost done. It just. Oh, because when I talk, especially because sometimes I'm having to talk loudly over people, my throat gets really dry. So this helps it from getting so dry. So what that means is on. Oh, that's not the solving part. I mean, that's the checking our answer part. So let's go ahead and go backwards. So we said we'd do subtract 1, bad 4, but 4 negative. So here we got to -2x is greater than 4. When we do this step, we divide by a negative. Again, it has nothing to do with the top number over here. Sometimes that number will be negative and you'll divide by a positive number. Doesn't matter what your answer is. It doesn't matter if the top number is negative. It's only when you divide or multiply by a negative, which is what we're doing right here. We are dividing by -2. So we need to say, oh, that's the trick. That's what Mr. Gill said I got to watch out for. So I need to now flip that sign. That's all you got to, other than, you got to know how to solve an equation. Other than knowing how to solve an equation, that's all you got to watch out for. So my answer actually is negative, or x is less than -2. And so 1, so we plugged in before a 1, right? Well, 1 is not less than -2, so we would not be able to plug that in. We have to pick a number less than, so we could plug -3 in, and -3 would work, which I can do real quick. -3 times -2 is +6. +6 plus 1 is 7. 7 is greater than 5. So now you can see that it works when you flip that sign. Just remember, divide or multiply by a negative, have to flip the symbol. If it's greater than or equal to, it becomes less than or equal to. All right, any questions? So I have some problems that I'm just going to put up on the board. I didn't print them out. It's not a whole lot to write down. Oh yeah, there they are. So they get really difficult after those. Actually, no, after number 12. So all you're doing is 1 through 12. Shouldn't take you a super long time. They're all just two-step equations. So you do 1 through 12. So don't worry about those. I mean, I guess you want to try those because eventually we'll get to those variables on both sides. If you want to try 13 and 14, you can, but 1 through 12 is your quiz next week, basically. Oh yeah, I'll pass out calculators. I don't want you using the blue one. They work completely different. You gotta put in things in different order. If you want to, again, this is not phone time. If you want to put a playlist on and listen to music, I'm fine with that as long as you're working. But if you want to quickly look at your grade, if you haven't seen your grade today, I put the quiz from last Monday. Not this Monday, that's not graded yet. But I put the quiz from last Monday in. There's only one grade. Just yesterday, like 20 of them. Oh, yeah, barely. I don't remember nothing. See calculator lying around, the white ones. God bless them. See, I got them. Time to work. Here. All right, so you have 45 minutes, probably even more than 45 minutes, just to learn one thing. I do not expect any bad grades next month. All of you had practice doing two-step equations at the beginning of the year, a lot of practice. This is the same thing. You don't have to worry about dividing by a negative. I don't think any of these have, yeah, none of these have a negative in front. So all of these problems are going to be, oh, you know what though? Shoot, no, they're not. I need to add a few in there. They don't have anything in front of the numbers. So here, I'll just give you a few to try real quick. 2x plus, and you have calculators, so you might get decimals. I'm not worried about decimals. You can leave it in fraction form if you do. And then we'll say what? There's some you also need to try. I didn't even notice that they don't have any numbers in front of those. I don't know. The goal. So if you said minus 13, would you be getting rid of the 18? You getting R by itself? Remember, always remember that goal, and that should help you know part of where you start. Trying to get the variable all alone. So you're trying to get rid of the stuff on the side where the variable. One through 12, and then the ones in blue are what you're responsible for the quiz. All right. Again, I don't, as long as you're working, I don't, not at least for this class, I don't worry about you checking the phone every once in a while. If you need to take a picture or something, that's fine for this class. Periods 2 and 5 don't get to do anything. Actually, some individuals have earned their way off of that, but the class as a whole doesn't get much. None of them work for the most part. Although fifth period get. If you have questions, say. Nothing less pushes on the ground. Forget that. Every single, well, not every week, but a lot of movies get put into the chart. And then they don't have it over the weekend. They need it. Normally, though, it's at the end of the day when they put it in the attendance. Into attendance, add attendance. We are missing a bunch of people. Make sure you write all of those down. You don't get to all of them because that's what you need to know for Monday. Let me do attendance real quick. Now here we go. Oh. Man, I can't see. Well, no, I'm trying to get it the right distance away from my screen to see it. These glasses only work at a certain distance. The way the prescription is. If I'm too far away, I can't see. If I'm too close, I can't see. Danielle's here, Josiah's here, not here. Here, not here. Justin's here, Sophia's here. Matt's here. Ellen. Max. David is here. Keon. Evelyn. Blake. Here, Jasmine's here. Zeke. Haley on here. Hogan's here. Evelyn's here. Oh, we didn't even do the book problem. So we might do some stuff with word problems on this. I don't know. We'll see. Hmm. Oh, no. Oh, I know. No. The wrong page. Oh, I was on the wrong page. There we go. So you guys actually got the whole lesson today. We'll have a little bit more practice time even on Monday. The other group will have to get so you'll be able to review probably for 15 or so minutes before the quiz. The other group will have to get the lesson and won't have as much. I don't think it's that difficult. What? Like a summer recording.